I get this one question from the Facebook. So please take a look here from REE and RME board exam problems and solutions. So this is the name of their group, no? Okay. So siguro tayo gagawa din tayo. Not siguro, surely gagawa po kami ng grupo naman ng mga nagre-review din, no? Tawagin nating REE and RME mentoring, no? Wala pang ganung pangalan sa Facebook. So, maggagawa po tayo mga kawerka, no? Okay? So that we can serve you better, no? Okay, this question came from Michael Angelo Gunay. Here is his question. 3 single-phase transformers are bumped delta Y. So, I will put here delta and Y. Okay, delta and Y. There. What should be the required turns ratio of each transformers to transform 10 MVA from 230 kV? 230 kV is a line-to-line voltage. Now, 230 kilovolts to 4160 volts. 4160 volts. Okay? The question is the required turns ratio. What is the required turns ratio? I got this question because this was given in the board examination. So there's a possibility this will be given again in REE, even in RME board examination. Okay. The transformation ratio or ratio of transformation, we have this formula. Our A, this is for 3-phase. Take note, the transformation ratio for 3-phase, that is equal to B phase primary over B phase secondary. Okay? There. This is also equal to N1 over N2. Number of turns in the primary, kung ilang ikot ng wire yon, number of turns on the primary divided by the number of turns on the secondary. And then, we have here I phase secondary. This should be secondary divided by I phase primary. Did you remember in single-phase transformer, we discussed before, no? The transformation ratio is 1:1:2, 2:1. Okay? Again. This is 1:1:2, 2:1. 1:1:2, 2:1. Okay? So, the basis is the phase voltage. The phase voltage. Remember that. We should know the basic of 3-phase voltages. In delta, remember, let us recall this. In delta, our line voltage is equal to phase voltage, isn't it? In Y, our line voltage or line-to-line voltage is equal to square root of 3 multiplied by the phase voltage. The phase voltage is what we call the coil voltage. Coil voltage. Remember, this 230 volts is a line-to-line voltage. That is our VL. Okay? To be specific, this is our VL on the primary side. This should be 1. Then if I have a voltmeter here, this is the V phase on the primary side. No? The voltage in the coil. No? Mismo yung voltage sa coil mo. So, This is your V phase secondary. There. Phase voltage. The 4160 is the line voltage at the secondary. Okay? We just have to get B phase 1 and B phase 2. So our B phase 1 is, what is this? B phase 1, take note. Obviously, our B phase 1 in delta, BL is equal to B phase, right? Our BL 230. Therefore, our B phase is also 230 because they are just in parallel. Remember, if there's a voltmeter here and the voltmeter here, no? These are just in parallel, equal voltages here, assumed to be balanced, no? If I will put the voltmeter here, so the voltmeter here in this coil will be in parallel with the line voltage, no? That's why they are equal, no? Okay? This is what I mean. If you are to transfer here and to transfer here, the line voltage will be equal to the phase voltage because they are in parallel. In Y, this is the line voltage. To get the phase voltage, this is the B phase secondary. To get the phase voltage here, this will become B phase, sorry. B phase will be equal to BL over square root of 3. Okay? So, therefore now, we are now ready to have this transformation ratio for 3-phase. Okay. What is the B phase primary? 230 volt. 230 kV. K means 1,000. Okay? Then divided by B phase secondary according to the formula. This is the B phase secondary. We have to divide the 4160 by square root of 3. Because of this formula here. BL over square root of 3. Huh? Because of this formula. Okay? So, because of this formula, BL over square root of 3, that is why we have here 4160 over square root of 3. Should be square root. Okay? So, kukuhanin mo muna to. Okay? I-divide mo to. Then, siya mo i-divide dito. Okay? Well, this is easy. No? We can go directly in our calculator. Or we can also make it 230,000. We can make it times square root of 3. Divided by 4160. So our answer is 95.72. 76, I mean. 95.76. 6242446. That is the answer. Okay, so this is the turns ratio also, which is the ratio of the primary to the secondary turns. This is my answer to this, to Mr. Michael Angelo Gunay. Okay? Always remember that our basis, okay, that our basis is our phase voltage. The phase value. Okay? The phase value. So, we have here the phase current, and we have the phase current on the secondary side divided by the phase current on the primary side. No? If I mean the phase current on the primary side, meaning that is the current in the coil here. Always remember that. I phase primary. What about the phase current on the secondary? This one. the current flowing in the coil. No? Yung mismong dumadaloy sa coil. That is our I-phase secondary. Mismong dumadaloy sa coil yon, yung I-phase secondary natin. No? Okay? Well, if you want to get our current, no? So our S is equal to square root of 3 line voltage times line current. No? Our line current is equal to S divided by square root of 3 multiplied by the line voltage. It's up to you whether you want to get the primary current or the secondary line current. Okay? It's up to you. No? Nasa sayo yun. No? So, what do I mean? If you will put this as 1, make this as 1. If you make this as 2, make this as 2. It's already given there so that you can calculate now for the current. But I want to complete my answer here. No? Actually, I am already complete. No? So, sobrahan ko pa. No? So, it's already complete because we already get the answer here. So, in delta, remember this. Our line current is equal to square root of 3 multiplied by the phase current. That is the basic of three-phase system. No? In Y, okay, in Y, our line current is equal to phase current. So, always remember this formula. No? Always remember this. That is for Y, and this is for delta. Connection of this transformer. Okay? So, these are the basic formula. No? Okay? So, those are some additional information you can get from this question. No? Okay? Let's go now to our next question here. Okay? Thank you.